Kurtz serves many industries, and the automotive industry has always been an innovation driver. The focus is on blazing new trails for human-machine interface solutions, organic surface designs, and realizing backlighting and touch operation as highly efficient production vehicle technology. Martin Hahn is Head of Application Technology and Innovation at Kurtz in Business Area Plastic Decoration and sheds some light on how innovation is practiced at Kurtz.
Innovation is certainly of utmost importance to Kurtz, and I can truly say that innovation is a tradition at Kurtz. The Kurtz family has lived this innovative spirit since the company was founded. Looking back, the first real gold hot stamping foil was registered for patent in 1930. The step from handcrafted gold leaf beating to industrial vapor deposition technology still characterizes the Kurtz company in its processes today. In order to develop the products of tomorrow and develop new processes according to the needs of our customers, as well as providing them with production solutions, we now see ourselves as a technology driver for a wide range of sectors and industries. Ultimately, the IMD VARIOFORM process is a further development of inmold decoration technology, expanded to allow decoration of three-dimensional products. Of course, this is an enormous step for us, since we have also implemented the deep drawing process into the in-mold decoration process. Typical switches and buttons are becoming obsolete and being replaced by connected surfaces and surfaces requiring more functionality. For us, this means generating a solution that will make it possible to produce these components in a single three-dimensional process as well. We also see a clear trend here that is not only apparent in automotive interiors, but also in many other industrial fields, such as household appliances and consumer goods. With IMD VARIOFORM technology, we have managed to merge several processes to bring decoration, forming, the three-dimensionality of the decoration, and functional integration into one process. This means we clearly save on downstream processes and the associated energy costs, and of course, we achieve a reduction in CO2 level. Using this industrial demonstration, the IMD VARIOFORM process has been built into the entire process chain, based on a complete production cell, and has been displayed at trade fairs and various demonstrations. This complete technology development, an entire process chain, won the Bavarian Innovation Prize 2020. We were thrilled, since a very large group here at the company supported this module development. The module was thus created, ultimately showing the entire VARIOFORM technology in the single image sector today, as well as showing the three-dimensionality behind it and the integration of the sensor. In order to show this entire process, we have, of course, had to go through a wide range of individual developments. I would like to mention the forming technology of the touch sensor, the three-dimensional forming technology to produce the insert, and I would particularly like to mention the laminate film, the entire thermoforming technology and its single image, and then of course the integration of this system as IMD VARIOFORM technology into the process. In the end, we required a total of 20 months as a team. Within the process flow, the VARIOFORM process runs like this. Initially, we use a laminate film from roll to roll, transport it via the roller feeder, heat it with infrared radiation, and then, of course, pull it into the cavity via the vacuum system. On the opposite side, we insert a three-dimensionally deformed sensor into the mold. And, after closing the two mold halves, the thermoplastic melt is injected between the two films. Upon opening, there is then a complete single image decoration on the front of the component in what's called the three-dimensionality of the component, and on the back, a functionality or functionalization via a capacitive touch sensor. We have produced and developed another innovation in the IMD PUR technology process, of course. This links the production of thermoplastic injection molding components, the decoration, and the additional integration of polyurethane as a protective layer. Development of the IMD PUR process was spurred entirely by the automotive industry. We are seeing a drastic change in front-end components, which of course leads to new functions for these components. They are becoming design and communication elements, so they must be transparent and radiolucent to display depth effects and enable other functions. The classic radiator grille or other design components that ultimately have a different function today are no longer necessary. This means that from a purely technological point of view, we are now using the IMD PUR process to apply protection to surfaces via polyurethane integration, to achieve depth effects, and also to create the high gloss properties of the surface, as well as other effects. The IMD PUR polyurethane technique is a combination of the thermoplastic element, IMD decoration, and polyurethane flooding. We have brought these three items together into one process step and into a complete process flow. What are the advantages of this IMD PUR technology? On the one hand, we can create the depth effect the components require. Another advantage is the integration of various design aspects. Design aspects can be incorporated into the middle layer, but there is also the opportunity to implement design aspects at different levels using IML technology. Individual images, as well as the corresponding decorations and the design variants, are freely selectable and also radiolucent. A very important feature is the polyurethane layer, which here traditionally replaces subsequent recoating and provides for the self-healing effect, thanks to the polyurethane. This means that small scratches that occurred during the product life cycle revert to their initial condition due to the effects of temperature, thereby again preventing scratches. IMD PUR technology provides a plethora of design options. We can implement the conventional transfer of decoration layers into the process, that is, classic car in-mold decoration themes, and the IML process. In this case, IML means a front glossy surface and a PC sheet printed on the back, which of course also displays a special depth effect at different decoration levels. We are happy to have won the Automotive Brand Contest 2020 with a design concept produced by IMD PUR Technology. The IMD PUR technology process flow is a challenge in the field of tool technology. This means that we combine thermoplastic injection molding with IMD and polyurethane flooding in a single process and in a single tool. Other advantages of polyurethane technology include the variety of options for wall thickness. Polyurethane makes it possible to achieve wall thicknesses from 0.3 mm to over 10 millimeters, which is not possible or only with difficulty with thermoplastic. On the other hand, we have succeeded in arranging the lacquer layers in such a way that the last layer, that is the top coat, forms the bonding layer to the polyurethane in this process technology. The chemical bond of these two creates outstanding adhesion between design and polyurethane.
But not just looks will count in the automobile of the future. Intelligent vehicle design will also affect interior design. Jörg Stierand, Head of Sales Management Automotive Europe at Kurtz, sees this as an opportunity for new, functional design concepts.
In almost all OEM concept studies and also in the vehicles that have emerged, we see a definite trend towards large seamless surfaces. Vehicles are equipped with ever more displays, including touch and non-touch variants. We are witnessing a transition from the conventional mechanical buttons and knobs familiar in old cars to capacitive applications that control everything, using touch sensors with haptic feedback, acoustic feedback, plus sometimes also with backlight feedback, and in many cases, a combination of all three. We are definitely also seeing the expansion of the HMI to exteriors. The front grille, in particular, plays a major role. The classic front grille, familiar from conventional combustion vehicles, loses its function in electric vehicles and can be omitted in many. In other vehicles, it is used as a design element and as a communication element as well, often even as a display installed and protected in the front of the car. We are also seeing typical design elements such as decorating strips in automobiles, increasingly equipped with additional functions. Whether just through backlighting for a pleasant ambience in the vehicle, or through additional functions, the decorative trim becomes part of the HMI, where functions in and around the car are controlled via design, through the trim strip. Another issue that has caught on in recent years is sustainability, a major factor in the automobile industry's future, and largely driven by efficiency and weight reduction in the vehicle.
Gewichtsreduktion im Fahrzeug ein großer Faktor für die zukünftige Ausrichtung im Automobilbereich ist.
Kurtz is also a leading innovation partner for the automotive industry when it comes to human-machine interfaces.
At Kurtz, we offer three main areas in the field of HMI solutions. One is surface with design, but also surface protection. Another is the functions we realize with our sensors, and thirdly, the integration, which allows us to apply the sensor to the component. In the field of surface technology, we offer a unique variety of options for our customers. In addition to hot stamping technology, IMD technology, and flexible technologies such as insert molding and high-pressure forming, we offer our customers a solution optimized for their need. We do not look to sell customers a product that might not meet their requirements. When it comes to sensors, we also attach great importance to wide-ranging design freedom in the layout. That is, everything can be implemented in our layouts, from a freely programmable matrix to preset keys and slide controls. When integrating sensors into a component, we are just as flexible and offer a wide variety of options coordinated with our customers, and then applied to our sensors in accordance with the customer end requirements.
Recht auf unsere Sensoren aufbringen. Durch diese große Vielzahl
With this wide range of options, Kurtz enables our customers to make the right decision with the right process.
richtige Entscheidung über den richtigen Prozess zu finden. Für den
The use of IMD technology in the automotive sector is clearly supported by the high degree of automation, combined with an almost endless number of design options.
an Designmöglichkeiten. Diese Designmöglichkeiten
These design options range from simple, clear codes, protective lacquers on the surface, to Shy-Tech, which means that a switched-off decoration is covered until a light source behind it makes subcomponents visible.
Sobald eine Lichtquelle dahinter erscheint, sind Teilelemente sichtbar. Darüber hinaus
We can also realize matte gloss effects, special effects, such as real metallization by NCVM, and tactile effects that can be applied precisely to symbols.
Symboliken aufgebracht werden können. Der große
The
Vorteil
big advantage of IMD technology is that our customers can use it to create components, decorate them, and integrate a protective lacquer onto the surface in a single process step.
auf der Oberfläche in einem Prozessschritt realisieren können.
But decoration is only one side of the coin at Kurtz. Built-in functions have become just as successful, at least in the automotive sector. Here are the concrete approaches for complete solutions in the field of human-machine interfaces.
Kurz denkt den Bereich
In the area of HMI, Kurtz thinks holistically. Our company network is able to deliver both components and turnkey solutions for our customers. From simple decoration and sensors to tools and the process.
und dem Prozess. Ein schönes Beispiel
A good example of where we have applied our network expertise is the HMI front panel example, in which we have decorated and made a 920 mm long component through IMD technology.
dekoriert und realisiert haben. Das Bauteil ist
The component is large, seamless, and curved, in line with trends we are seeing in the automotive market.
Markt im Automobilbereich wahrnehmen. Realisiert ist das Ganze.
It has all been done with an IMD single image in Shy-Tech.
Das bedeutet, dass wir
This means that we have a day and a night design.
ohne Hinterleuchtung haben
Without backlighting, there is a visually appealing plain surface. With backlighting, light penetrates some of the surface.
neben den dekorativen Aspekten
In addition to the decorative aspects, we have back-injected a sensor in the display area through IML technology, and via our full bonding process, subsequently created another sensor for touch and slide functions next to the display.
Vollbonding-Prozess realisiert. Unser
Our HMI front panel concept has even won the Red Dot Design Award.
Dot Design Award gewonnen. Das freut uns besonders.
This really thrills us because it shows that we are on the right track with our
auf
solutions.
dem richtigen Weg sind. Wir haben uns bei diesem
We chose the IMD process for this concept because it does not affect recyclability.
Beeinträchtigung der Recyclingfähigkeit bedeutet. Die dünnen
The thin layers of lacquer we apply in our IMD process do not impair the recyclability of the component.
Bauteiles nicht. Der IMD-Prozess
IMD is a roll-to-roll process.
damit verbunden haben
Linked to this is our customers' high degree of automation in their component production, which includes decoration and equipping with protective lacquer.
selbst läuft
The process itself uses a foil feed to insert the polyester carriers into a tool, where it is positioned vertically and horizontally.
Vorschubgerät dort vertikal und horizontal positioniert werden. Im Anschluss schließt
The
das
tool
Werkzeug.
then closes.
Vakuum wird die Folie
The film is drawn into the cavity by a vacuum.
Im Anschluss
This
daran
is followed by spraying directly onto the lacquer package on the PET carrier.
über die Temperatur den Druck
Temperature, pressure, and embossing time then detach the paint layers from the polyester carrier onto the component for a finished part that includes decoration and protective lacquer.
dem Dekor und dem Schutzlack vorliegen.
Subsequent cleaning is still required, in some cases UV cured, and then the component can pass to the next step in the value chain. The major strengths of the IMD process lie in the fact that the component is created and the decoration and protective coating are implemented in one process step. Our IMD technology products provide our customers with a wide variety of aesthetic and functional designs to choose from. These include, among others, wood, NCVM real metallized decorations, and partially backlit decoration through Shy-Tech technology. Tactile elements and much more are possible. We can also apply beautiful decoration to recyclates. Another big advantage of IMD technology is that we can change decoration by simply changing roles. This usually takes 5 to 10 minutes. It makes the IMD process significantly superior to many other processes in changeover to another decoration. Plastic surfaces in automotive interiors are of utmost importance and often very elaborately decorated. Instead of the usual task of having to make a hole in panels to incorporate switching elements, touch sensors also allow these surfaces to be completely closed, integrating the touch elements together with the lighting elements. The control elements can be simple buttons, but can also be slide controls, for example to change the lighting or color of a lit surface, or to control ventilation, or simple buttons to switch something on and off, including the complete touchscreen familiar in cars. Thanks to their flexibility, the touch sensors also allow for any layout of the sensor systems. This provides for a very high-quality, functional HMI interface in cars. Poly-TC touch sensors consist of flexible, transparent polyester films printed with conductive and transparent layers. And they are very easy to integrate into surfaces, especially plastic surfaces. This applies to both automotive interiors and white goods, to consumer goods such as coffee machines and similar items, and to industrial controls and surfaces. The touch functionality allows for a closed surface, and this flexibility also allows for 3D geometry, which is currently an interesting trend that makes more organic forms possible. And with our integration know-how, the sensors can be applied by the most appropriate integration method and according to application, whether mechanical clamping, lamination, injection, or even functional foil bonding. Capacitive touch sensors are now familiar from smartphones, where they are easily used without thinking about how they work. But they are also familiar from almost all control elements in cars, on white goods, and consumer goods, where mechanical keys are being replaced by such capacitive keys. They function by approaching them with a conductive finger, which the switches then detect as an indication for an operation. This requires making sensors with high sensitivity, which we do very well with our poly-TC touch sensors. With our foils, we have highly electrical conductive materials that simultaneously provide a high degree of transparency. This is very important, especially if the component is backlit, either with symbols or a display. Poly-TC touch sensors also provide high transparency, and high color fastness. This is particularly important for design elements so that the color with which they are backlit remains exactly the same and does not change with the sensors. The sensors must still be flexible because they are angled and 3D surfaces. Our sensors are manufactured in roll-to-roll production, which also makes them very attractive for large runs. At Poly-IC, we produce touch sensors with the Kurtz group, where we also have the opportunity to furnish control panels with appropriate decoration, to backlight them, and to display these components as joint elements, combining function and decoration. Which is, of course, very much in line with the current trend for all interior and control elements. We can realize the entire range of operating elements with our touch sensors. This begins with a simple button, where normally there is a mechanical switch integrated somewhere and composed of one or more mechanical parts. It is now simply a film that detects the approximation of a finger and thus knows that someone wants to operate something. These control elements can also be combined into several on one film. So, there is already a great advantage in having one control element, when 5 individual keys normally require 5 components. The capacitive field requires only a single film with 5 buttons that can be integrated into the layout, providing for a beautiful, comprehensive control unit. A slide control can be generated from these individual keys and buttons via the appropriate layout. This slider allows continuously variable operation over a certain area, where, for instance, it can be used to adjust lighting, ventilation, heating, and similar. If this one dimension of the slider is expanded by creating a matrix in a second dimension, then any location on a surface, like a computer touchpad, can be highlighted with a finger to freely design with the software whatever one wishes. Either fixed keys that are designed using software, or move, write, or enlarge things using multi-touch, as one is used with a smartphone. And this matrix can, of course, also be realized as a touchscreen in front of a display, and thereby a touchscreen similar to the ones in smartphones and cars. This capacitive operation would also be specifically suited to proximity switches. So certain types of sensors reveal whether proximity of the hand can start certain actions, whereas gesture control detects hand movement near a sensor. As well as functionality, we must also address sensor integration. This comes out in every customer dialogue. Here too, our major advantage lies in the wide range of possibilities we offer, and to our knowledge, unequaled by anyone else. It starts with the simple mechanical repair of sensors by clamping them between 2 fixed panels. This works well for small sensors. The most commonly used method is adhesive labels or pressure-sensitive adhesives. This is common practice if you want to create simple backlit symbols. If you want a display with a touch screen, optical clear adhesive is often used. This is a high-quality adhesive system with a premium appearance, where the sensor is laminated to the panel with clean room quality. And then there are further options that are, shall we say, a bit more modern. On one side is in-mold labeling, where the sensor is directly inserted during the injection process. The great advantage is that this is a one-step process. Actually inserting the decoration, which is an IMD or IML decoration, while injecting a component, a process that's available anyway, while at the same time inserting a sensor on the back of the panel, allows for terrific integration options. Last but not least, there is our functional foil bonding FFB process, whereby the sensor is integrated into the back of a previously manufactured and pre-selected panel in a post-mold process. There is a wide range of options. The classic functional foil bonding process is up-down stamping, whereby the sensor is pressed onto the component via a hot stamp. The sensor contains a primer, that is, an adhesive system, which is only activated by pressure and temperature. This is done by pressing the stamp on at a quite high temperature, typically 200 to 230 degrees Celsius. At a certain pressure, for a few seconds pressure is applied, the glue is activated, adheres to the material, the stamp goes down, and the part is finished. And we also offer a second process for larger and for more display-type components. It is a roll-on process, in which a hot roller stamp rolls over the panel for even better optical quality. We run the two methods here at Kurtz, and also supply the necessary machines. It is usually advantageous for a simple company to be able to offer this. With this component, it is easy to see the different features I just explained. This is a door control unit for operating the door windows and door lock, as well as the rear view mirror. This is a control panel with a 3D exterior shape and Chi-Tech trim, where the symbols only become visible when the whole thing is switched on. The sensor is attached to the back and integrated into the functional foil bonding process via up and down stamping. And thanks to the temperature and pressure of the stamp, even a 3D shape can be realized in two places on the back. In the upper area, there is a dome that is copied. And in the lower area, this pyramid-shaped 3D structure can also be directly achieved with functional foil bonding. With this component, an instrument panel that can be used in the automotive HMI sector, we at Kurtz have shown how we handle innovation, how we implement decoration within the injection molding process, for example, here in the IMD process, which also enables backlighting in Chi-Tech, and how we adapt to circumstances to integrate different sensors into components. At Kurtz, we are proud that this component and its design concept has been awarded the Red Dot Award. It has integrated everything we have presented, from innovation and design, plus decoration methods to the sensors. We hope we have piqued your curiosity